sida lerisda mung yenga siko koi na hojik uncontrolled chain reaction yengre. Now this is to be controlled in our nuclear reactor because this much of energy cannot be harnessed. Harness I think koi na pamisi kai no energy never. Physics study we study physics to harness or to collect energy never. But this type of this energy release in our uncontrolled chain reaction, this is very quick and this is very huge already. Now we cannot harness it, therefore we have to control this. Control the whatever this reaction is possible due to the extra neutron limit to se machine number mo. So we have to take out this extra neutron je ko extract the wave, and that will be done by absorber. And in your nuclear reactor we have one component. That component will be known as absorber component, and that will be made from carbon or graphite. Graphite ki mana made to gane ko machine na maram horaga your excess neutron will be absorbed by your absorber hangani ko, so that our nuclear reaction can be proceed one by one among the control chain. Okay, therefore every step will produce 200 mega electron volt of energy lakani hangani ko. And point to be remembered second in your formula book it is written as critical mass hamunga nangi critical mass hamung yaw critical mass high taragati. Even though uranium 235 is radioactive in nature, but it is most likely to break down. Even though this is most likely to break down, it will not break down or it will not undergo nuclear fission reaction unless it has some certain minimum quantity kara darkar ta hai yaga. Say uranium 235 low rekhala jeba. Now if you have minor logic, the critical mass for uranium 235 say if you have 50 gram, this minor we have 500 grams say, unless we have 500 gram of uranium 235 it will not undergo nuclear reaction. Hai taragati ke dautar hai, we must have this much of mass. Once your uranium 235 is gathered so that it is about 500 gram, it will undergo nuclear fission reaction unless 250 it will not undergo nuclear fission reaction. So this is very favorable for us for making bomb atom bomb sizes. My critical mass our critical mass will be 500 this is 300 compartment and it will be separated by another 200 compartment, 200 kg, 200 gram. This is 200 gram. Now this is being dropped due to the impact pressure or impact force. This 300 will come in contact with 200 grams so that it will start nuclear fission reaction. Atom bomb there will be two compartments. Number one, the critical mass whenever your nuclear fission fissile material like uranium 235 say, this will be known as nuclear fissile. Fissile है because fissile program में fissile material है fissile material से unless it attains critical mass it will not undergo fission reaction. Now we will discuss the two different types of nuclear fission reaction for uranium 235. You have to copy the equation copy the you have to remember this. Uranium 235 ki it undergoes two different types of nuclear fission reaction, and it will be first number one the uranium 235 plus neutron di kay hari neutron di it will have mass but it will not have any charge. My charge it will undergo this nuclear disintegration. Barium plus krypton plus 3 SS neutron plus 200. Mana see the period is coming period say we have two different reaction only period ko reaction only is the you see the basic difference here. The daughter nuclei will be quite different. If three free neutrons are produced, then the daughter nuclei will be barium and the krypton. Barium ga krypton ga ore ko aduga karigumba reaction after the reaction if two free neutrons are produced, neutron ani puthokota ragadi your product will be or daughter nuclei will be xenon ga strontium ga already. Aduga what about the amount of heat release? The amount of heat release remain the same, that is 200 mega electron volt of heat release. Yara tha yare ko sima khange nang ki formula tu da kari mu yauri atokpa nuclear fusion reaction we have already discussed yesterday also. Formula number 6 ko na discuss ta ore ko abidi the mass asima discuss ta dusu yare yung sida nuclear fission ga fusion ga je energy kana release to we nuclear fission reaction dadi it produces 200 mega electron volt of energy produced ta unatra and nuclear fusion dadi kya produce to we 26 mega electron volt of energy is produced. So we do not have fusion reactor hapte. Koi sum ta ka tam badan nuclear reactor hanta bisa. It is fission reactor, fission integration to guna nuclear disintegration to wasna it produces more energy than that of nuclear integration. Magi kano to wudu di fusion thokpada idi fission na heliko kana base adu ini we back nuclear fission reactor. Yara next the radioactivity, like this is very important. Now we will discuss the different type of radioactivity. Radioactivity is what is the basic difference between your nuclear fission reaction and radioactivity. Radioactivity ga animal disintegration fission this is caused due to this is the breaking down of heavy nuclei, by external agent which is usually neutrons na bombard the disintegrate the one nuclear fission reaction. Next lies the radioactivity and radioactivity this is the disintegration of a given heavy nuclei by itself. By itself, that will be known as by itself. The disintegration of heavy nucleus into lighter daughter nuclei by itself will be known as radioactivity. This is very important because you are pursuing your medical career pursuit of you will be dealing with X-ray, CT scan, MRI. They are all based on your radioactivity. X-ray that will be discussed in your radioactivity. Radiotherapy department hospital radiotherapy and cancer now now see that is a very simple way. There are three particles that can be emitted by radioactivity. the nucleus, heavy nucleus. We have a heavy nucleus, and if this is to be disintegrated into daughter nuclei A and B, A and B is the disintegrate of the it can produce three different types of radiation. Radiation first radiation will be known as alpha particle. Alpha radiation or alpha particle. Next beta radiation or beta particle. Alpha alpha can be written as it is comparable to helium nucleus. Beta particle, this is simply an electron. Gamma, this is neutral particle, or you can consider this to be a photon of energy in a low share. Simple radioactivity is the self disintegration, self breakdown of a heavy nuclei by emitting alpha particle, beta particle, and gamma particle. Now we will discuss in detail what is alpha particle, what is beta particle. Alpha particle is usually taken as positive, the beta na negative, and this is neutral. Diagram number 1 your alpha particle or alpha rays bend towards the negative plate. Beta particles bend towards the positive plate. Whereas your gamma radiation doesn't bend in either way. Positive to bend tauke, negative to bend tauke. Straight now let us discuss in detail what will be the nature of alpha decay, what will be the nature of beta decay, and what will be the nature of gamma decay. This is very important because we are going to discuss the nuclear reaction, nuclear disintegration reaction. Your alpha decay, what will be the equation for your alpha decay? For alpha decay, let us consider this to be the radioactive nuclide technically. It has atomic number Z and mass number A. When it disintegrates, when it undergoes nuclear disintegration, radioactivity set your new daughter nuclei will be Z minus 2 A minus 4 because we know that alpha particle is exactly equal to helium nuclei. There must be conservation of charges and there must be conservation of mass. Total charge is Z helium which is alpha particle alpha particle it carries two positive charge particle Z minus 2 plus 2. Total charge would be Z rank Z product Z. And magi mass number mass number is A minus 4 plus 4 A tabra very simple whenever the atomic number is decreased by 2 or if the mass number is decreased by 4, then it will undergo or it must undergo alpha radiation. This is the first case. Next, number 2, the second, the beta decay. This is beta decay. Beta decay is this is this is somewhat important related to your concept of stability. Beta decay according to your beta decay, we define the stability of a nucleus. Nucleus stability is calculate. Here very simple, let us take helium homology. Why do we have this helium as stable? If we look at the nucleus What? How many protons will be there? Proton kya yaubani? 2 yaubra. 2 protons. Because the number of atomic number will be exactly equal to number of protons kemana bra? Atomic number is equal to number of protons kemana? Yare. And mass number ID, number of proton plus number of neutron. So we will be having 2 neutron. Sida kari hai kena. Number of kena mana rese? Number of proton siga, number of neutron siga mobile si mana bra mana dabra mana re. Whenever nang hangga se whenever inside a nucleus amagi manungda, if the number of protons and number of neutrons are equal, then that particular nucleus is stable whenever, unless maze stable kano itaragadi stable kareba unequal itari, it will be whenever se unstable company. Let us see the basic difference nan kena difference siko. We consider samana law ecology. Understand the one thing. If you understand this, then your beta decay is very easy. Otherwise, it will be very difficult. This is hypothetical condition. Hypothetical condition. We have 3 neutrons. 3 neutrons. One proton. That is number of neutron is more than the number of proton. Proton masing lagi neutron masing hendra heli. Yang taiko adu di under such condition siswa namu haige. Koi le se gari am chen mani ko adu le makon yam hori se condition ani sida. Above case ta kaile se number of neutron is more than number of proton. Aduga second case ta kaile re number of proton is more than number of neutron dagi hendra heli. Yan tai ko adu itar sida ke mane itare we must stable ho nang je every time angry or lego pam rane. Do you want to remain angry or happy for 24 hours nang lego ngam rane? Happy 24 hours lego ngam de ade sad 24 hours lego ngam de dra. So that stable configuration normal halakta hai. Normal this neutron is to be converted, the excess neutron is to be converted into proton na convert hota hai. So this conversion se kai hota hai si neutron se na convert hota di kai gani, we are decrease in the number of neutron decrease tawre, whereas number of proton masing je galak tabra by 1 so that 2 neutron 2 proton stable. Yabra yareko if there is excess neutron that excess neutron will be converted into proton. Finish. Now silong lo receiver silong matam the proton excess proton se this is to be converted into kanada converter utare neutron ka convert over toroi here silana z plus 1 amla pra atomic number han 1 le dagi 2 la pra positive proton hingata di number of proton is equal to atomic number having na initially there were 1 le dagi magi plus 1 amla hapsa 32 tara pra tare sida kai atomic number is decreased by minus 1 amla pra understand the way whenever there is conversion of neutron into proton convert hota रहती we have atomic number increased by 1. Whenever we have excess proton, it will be converted into neutron convert होगा by releasing your beta radius याद को now अब तक हनी सिग्नल की formula number एदा नंगे beta दिखे positive beta दिखे negative beta दिखे न p बरा p को हान बकिए सिर्फ इंग सी neutron gidi we know that it will have no charge mass charge mita like na but it will be having some mass mass something like that already mass like 1 0 will represent the neutral condition for neutron की charge something out to be 0 mass like 1 hangani ko it is now converted into proton. Proton gidi kai lei ni charge lebra lei, mass lebra lei. There must be conservation lei hai ko. There must be conservation of charges and there must be conservation of kanao gidi no mass number have not drop. This is kai la kani set. E, this is minus 1, this is 0, that is negative labra. Sikilani plus nang biro negative beta decay. Understand tawre? Kya tahu bro? Kali magta ko na sida minus 1 lagi no. 0 le natra 1 minus 1 0 tabra 1 plus 0. Electron namagi charge ko lo bro. Lo electron namagi mass consider to bro. Do we consider the mass of an electron? No, we do not consider. Therefore, it is 0. 1 plus 0, mass number remain 1. And what about the atomic number or charge? It will be 0. 1 minus 1 0. Whenever if there is excess neutron, excess neutron, it must be converted into proton. And this will be known as negative beta decay. Negative beta decay company. And what would be the equation? My equation is similarly, one negative beta decay ma lakhta is kamay beta. Our atomic number increases or decreases? Increase the week, increase the week. Increase the week. This will be y z plus 1. What about the mass number? Mass number change the bro. Mass number change the urane. This is 1 1 bro. Here this will be sorry we take the mass of a neutron and proton equal in 3 neutron plus 1 proton, it will be 4 still. When 1 neutron is converted into proton, we will be having 4 because we assume that mass of a proton and the mass of a neutron are equal. Whenever there is increase in the atomic number by 1 without changing the mass number, then the type of radiation will be negative beta decay. Negative beta decay. Understand tawre? Remaining the mana entry neutron there is not required. We have to simply understand for negative beta decay there must be an increase in the atomic number by 1. Number of proton increases by 1. Mass number change next number beta kailai excess proton 1 this is to be now converted into neutron. Neutron this is 0 1 plus positron E this is 1 and this is 0. This is known as positron. It will have charge equivalent to an electron, but it will have zero mass negative. I equal later the opposite plus minus amana meter or antimatter layer. When the male female light electron carries negative charge. Electron opposite to company that will be positron company. Bro, proton heavier deva charge 3 maneva. However, mass the lakan what is the mass of an electron? 0 litana. What is the mass of a positron? 0. What is the charge of a positron? This is 1. Let us find out the conservation. Conservation of charge 0 plus 1 1. 1 plus 0 conservation of mass. That means number of proton decreases. Number of proton decreases. Proton decrease the your Z into this is E mahapiro. This will be Y mahapirani Z minus 1 A mahapera. Number 2 4 plus this is positive beta decay. Positive beta decay. Yeah, bro. I negative beta decay your atomic number is increased by 1. And positive beta decay your atomic number is decreased by 1. However, we do not have any change in the mass number. Mass number the change. Okay, so not going to be noted. Yadra, got it. Now let us consider the last radiation. There is gamma radiation. Gamma radiation I will be explaining from our formula by Barber Mota Itage ko. Mana piri si kamay pire. Excited state na pibra pidabra pire ko. Whenever any nuclear radiation, whenever any nucleus undergo excitation means it will undergo vibration mode. Ma vibration tawre kana zen hit thara obtain tawre ma vibration mode ta lagtara gadi it will generate why the excitation is there. Yadra ma disintegration thokra thokti. Is there any disintegration? No. Disintegration thokta vida if a particular nucleus undergoes vibration mode or undergoes excited state, it will produce the photon produce the it will produce radiation of neutral polarity charge the pudava light kumba na putugane yaga yarani ko adina mas dei khangis dati mo. You look at the magi nuclear reactions de mo, only alpha radiation produce decrease in the atomic mass. Atomic mass decrease to what? Atomic mass change to karama matlab change tawi only alpha decay the change tawi. However, your beta decay the gamma decay the is there any decrease in the atomic mass? Like they go, whenever there is decrease in the atomic mass, you should remember that at least one alpha radiation must be produced. Yagadra, atomic numbers is changed. It may be alpha radiation or it may be gamma radiation. It may be beta radiation. How many? Alpha radiation na decrease by 2, gamma radiation, beta radiation na increase by 1 or decrease by 1. Atomic number. How many ko? Gamma radiation tadi nothing is changed. Time to change something. Yaga. Got it. Now let us do our question number. Is it? Question number 19 ko what correct? Question number 19 is a repeated question. When answer target to what 3.125 to data for what 13 target niko. Option number 4. Yesterday we have done this one. Tingnan ko what correct. Question number 20 for this question number 20 we have a reaction. See, I hope you all can do this. For your question number 20 we have IS1 2 plus IS1 2 it gives 2 IS3 plus N01 similar natra. The mana is we have a nuclear fusion reaction number period. If the mass of a deuterium say deuterium atom, see deuterium has in a top, see deuterium on the top, mass kya no. am like that. See, Kamaina, already it's very simple. This is similar to one of the questions which we have done today. When Mamang the previous your Q rectan Amahita DQ rectan will be equal to very simple. My mass beta D, this is 2.01471 plus 2.01471 into this is 9.31. See, to the Panata, you find out the energy difference and you will get the answer. Yare, I skip the okay. Next question number 22. 22 so what correct? 22 is some money. 22 is exactly equal to your question number 19. 19 is some money. Some another one party on the Manadro. Manadreco. Question number 16 there. Sorry, question number 19 there. Question number 20. 22 of my draft. 22 there. Question number question number 6 lah. Question number 6 tu sama nak mana rekod. Nana kalau tu bila question number 6 han pather bina na 19 ni mapada equal to question number 6. Aduga 22 ni mapada so equal to question number 6. Thabi na mo yadra. Khangani ko. Aduga question number nangi hocharo kaini na khale question number 24 se repeated oile anjan anjan ko pang morot magi samane ko binding energy period na tro si haini na khali. Then we skip this makantoge. Question number 25 so it is also very easy. Samanani 25 say bola mo abra mana power is given p na tro I see my repeat again question number 25. What is the power given? 300 megawatt. Mega means 10 to the power 6. My actual unit is watt. My power unit is watt. And then you see the this will be heat divided by time. Power is rate of heat production, and this will be 300 into 10 to the power 6 among time. Question is power gain. Man, how do you say? The energy released during fission during fission of 1 uranium-238 cell 170 megaelectron volt the number of the uranium atom. See, also very simple one. Q is N E N A uranium-238 uranium-238. This is breakdown. This undergo nuclear reaction. Nuclear reaction it will produce daughter nuclei A, daughter nuclei B produce plus it will produce 170 mega electron volt of energy produce how many such uranium-235 is to be taken along the gate. Uranium-235, the number of uranium-238 that is to be taken so that altogether it can produce 300 megawatt of energy, megawatt of power. Yagatra, understand the Wungamiko? Very simple way now. Magi, Ama pyramid 170 pyramid. We can have this number of nuclei that is represented by N Mahapasi, and it will be 170 mega electron volt divided by times pyramid. 1 hour pibra. It must be converted into second. 1 hour, this is 1 hour, and this is 300 into 10 to the power 6. Now, simplification. Then the final together is 300 into 10 to the power 6 into 1 hour. 1 hour it will be 60 minutes into 60 seconds. 60 into 60 and 60 into 60 divided by 170 into क्या माना नहीं 1 मेगा इलेक्ट्रॉन वोल्ट से क्या मानी 1.6 into 10 to power minus 13 सिंह ही माना अपना था यार you calculate this at your home and you will get the answer from there approximate होने पर लोग extra ये को 1010 get cancel out 10 to power क्या next है 38 निपन मापन 22 3 into 6 into 6 divided by 10 to power 22 is ready 17 into 1.6 yeah then 10 to power 22 भी approximation तार याद रहो question number 29 sir 29 is exactly equal to this question number 25 when was bol is because some mane ko mana is what is being asked we have to find out the mass of uranium 235 that is simply if we know the number when I can come with the if we know the if we know the number of nucleus we can easily find out the mass number पर पे आपका यूं सोने का लगता है ओके यूरेनियम 235 से सिग्नल कंफ्यूजन सब पे आ देगा यूरेनियम 235 this is in terms of atomic mass in natra what will be the total number they find out the rectal zeba if we get the total number of nucleus that is required for that production mana 1 megawatt have natra for 1 megawatt of power production we require let us assume that we require 100 required to rectal zeba 100 your 100 uranium 235 is being required 235 se required hoita di we can easily find out the mass have the 1 uranium 235 se kya mane it is this is one atomic mass unit se kya mane 1.0067 into 10 to power kya no beginning of the formula diya huwa idna ating yenge ko 1.66 into 10 to power minus 27 number fibra beginning of our one atomic mass unit term height 1.66 and it is a 1.66 or rather 1.67 into 10 to power minus 27 kg tabra minus the kya yaromi uranium 235 ki dadi uranium 235 ai ni is ai hai kham ramo khang ni da uranium 235 sita le se how many atomic mass unit one nucleus will represent like 235 so 235 atomic mass unit will be present for one nucleus khang ni ko for one atom or for one nucleus we will be having 235 atomic mass unit so when this is converted 235 into one atomic mass unit can be related to 1.67 into you take this as side note on the notation below 1.67 into 10 to power minus 27 and this will be in terms of kg yung tarba hanggang niko but one uranium 235 ki mass se kya manani the mass of one uranium 235 will be equal to this mass ni tarba tare how many number can be calculated from our this formula question number 25 ki da when a proceed to you proceed just like your question number 25 just like question number 25 tagi we calculate a number khungya bra n c value je we calculate it as 100 and data the total mass m total will be equal to 1 uranium 235 is this much of heavy this is n into this is m1 am have ya brother bro and you will get answer this is 235 into 1.67 into 10 to the power minus 27 into number se kya no, you calculate the number as 100 and lakh matra 100 say this is not the actual value, okay, you have to calculate by yourself just as in the case of question number 65. The lower we are done with one question in the nuclear fusion next evening class evening class nuclear alpha radiation gamma radiation based question calculate and today we will complete this chapter.